Good morning, class. Happy Monday. Welcome to another week of online learning. Today we are continuing to learn about ratio in math, okay? So grab your anchor charts so you can have them handy because they will continue to be helpful to you today as we continue learning. Because today we're learning about equivalent ratios, which is the second example here on this page, okay? Because as you can see, there are 9 oranges and there are 6 watermelons, but the ratio is 3 to 2. And the reason this is because both 9 and 6 can be divided by 3. And 9 divided by 3 is 3, and 6 divided by 3 is 2. So this is that ratio in its simplest form, okay? Which is what we're going to be doing a lot today, because remember, ratio is relating to quantities. So it's not the exact number. It's about the relative sizes, okay? So let's take a look at that. We're going to use our textbook to learn more about this. So if you can open your textbook to page 75, this is what we're going to be looking at today. Okay? So let's get started. So it says that John has 8 cents and Peter has 12 cents. So I've got John here and Peter here. Okay, so the ratio of John's money to Peter's money is 8 to 12. So that's the actual number of each of their pennies, right? So that's the first step. But we can actually turn this into units, right? So we can put them into groups of 2 to get 4 units and 6 units, which I'm going to do with pink because we know that both of these can be put in groups of 2. So let's see. So John's, you're going to get 4 groups of 2 pennies. And Peter, we can see, has 6 groups of 2 pennies. 1, 2, 3, 4, 5, 6. So this ratio has now become 4 to 6. Okay, because there are 4 groups of 2 pennies to 6 groups of 2 pennies. All right? But as you can see, you can go even further than that. So you can split the number of pennies into 2 units and 3 units, which we'll show with red, okay? So we'll take the same whole, and this time we're just going to split it in half because now these are groups of 4 pennies, okay? And then we can do the same with this one. And we're going to split it here and here because these are all sets of 4 pennies now. Okay, which means our ratio now becomes 2 to 3, which is in its simplest form. We can't go any smaller than that. We can't make any different units than that. But all 3 of these are equivalent ratios, which means they show the same relationship to each other, the same amount of quantities to each other, okay? And basically what we did here, to simplify it on each step, is divided by 2 on each side along the way. So do you see how that works? So it's the same as when we were doing fractions and we simplified. We're finding a common factor that we can apply to both sides. Okay? So if you need to, you can get your divisibility rules out from last week's anchor charts because that can be helpful to you too, so you know what common factors might be possible, okay? So now we're going to look at a couple more examples of ratios and putting them in their simplest form. So if you can flip the page with me, we're going to go on page 76 and look at these examples. And I want you to be mindful of the thought bubbles especially, okay? Because it says to write each ratio in its simplest form. And it starts with number 1. Our ratio given is 4 to 10, okay, which I have right here. But the thought bubble says 2 is a common factor of 4 and 10. So we're going to divide both 4 and 10 by 2. So I'm going to give you a little divide. And 4 divided by 2 is 2. And 10 divided by 2 is 5. So the ratio is 2 to 5. And remember our little colon in the middle. All right, so then let's look at example 2. So it's giving us our ratio of 12 to 18, And our thought bubble tells us that 6 is a common factor of 12 and 18. So we're going to divide both of those by 6. So 12 divided by 6 is 2, and 18 divided by 6 is 3. So our ratio is 2 to 3. And remember, again, the colon in the middle. Okay, so do you see how that works? So we're dividing each side by the common factor that they have. Okay, so let's look at a couple more examples. We're going to look at examples 3 and 4, which are word problems that are asking us for the same thing. Okay, so number 3 says there are 15 ducks and 12 chickens on a farm. Find the ratio of the number of ducks to the number of chickens. Okay, so it's given us the ratio at first, which is 15 to 12, and we're going to simplify it. So thinking about it, I know that both 15 and 12 can be divided by 3. So I'm going to do that to both sides. So 15 divided by 3 is 5, and 12 divided by 3 is 4. So the ratio of the number of ducks to the number of chickens is 5 to 4. All right, and just one more example, number 4, it tells us there are 40 students in a class. 25 of them are boys. Find the ratio of the number of boys to the number of girls in the class. So it's helpfully given us the subtraction to find the number of girls, which is 15. So that means our starting ratio is 25 to 15, which is right up here. But we need to simplify that. So I know that I can divide both of these by 5, so I'm going to start there. So 25 divided by 5 is 5, and 15 divided by 5 is 3. So that means that the ratio of the number of boys to the number of girls is 5 to 3. All right, so that is how it works. That is how equivalent ratios work and how you are going to be simplifying them. So now it's your turn. You're going to be working in your workbook today, and it's exercise 35, okay? So I know in your chart it says exercise 36, but it's actually exercise 35, but it is on page 84 and 85, okay? So hop to it and let me know if you have any questions. And of course, I will see you on Thursday if you'd like to talk about this as well. All right?